That was a tremendous presentation. Absolutely wonderful. Thank you so much, sir, for sharing that with us. Okay, so let me put it back on speaker view. Okay, and let me see, who would like to go first for questions? Okay, and sorry, I need to go through chat here. There's Jeremy Rees. Go ahead, sir.
Can you guys hear me?
Yes. Can you turn your camera on, Jeremy?
1 second. I can't turn my camera on. I don't know why. It's interfering with the streaming software because we're streaming live right now, and I opened that first, so it won't let me use the camera on Zoom. Sorry. We had a couple questions. You had mentioned a slide with the model submarine and talked about a video where you could see this thing turning, and then you mentioned another video too. I wonder if you could provide links to those videos so we could share those and get a hold of those. If you can, that would be awesome.
Let me get my cursor under control. Where's my cursor?
Oh, and you may have to go back into screen sharing.
Okay. That was part 1 or part 2?
Part 2, I believe, with the submarine. It might have been part 1, actually, the end of it.
Okay.
Yeah, actually, it was the middle of part 2. I'm sorry.
The middle of it.
Middle of part 2. Okay. I am such a forgetful person. I forget what I've done, where I've done it. No, I think it's part 1.
How come they can't hear me?
Oh yeah, you're right. I think it's part 2. That's right, here. Here, this is the person, this is the link this is the link to all his stuff. This is the link to one of the particulars. Click on it so we can.
Sorry, again, it's on the wrong screen. So while you're doing that, I actually have a couple of other questions I should jump into real quick.
Okay.
Yeah, I'd like to get the video.
Slide 15 or 19.
I don't want to take up the time and run out the clock. We have a limited amount of time with the questions and stuff. But yeah, post the video, post the link in the description so I can post it in the chat and everything. And I'll let someone else have a turn.
Okay, thank you, Jeremy. Okay, let me go to Mohammed next. Sir, go ahead.
Thank you. Thank you for letting me on. Just want to go quick one. First of all, great presentation. Love the way you represented and love the way you explained it to it. So it took like a hockey stick to gain interest into it, a hockey stick movement. I just want to quickly ask is the engineering model that you've represented on your slides. What are your opinions about using plasma as a replacement for neodymium magnets and then closing it with either an outer junction or an inner junction of two different metals in case of a steel or an aluminum? I mean, just wondering, what would be your views on that? If we are able to rotate plasma and kind of produce something similar to that as an engineering aspect?
Great question. I can say this, even though I may have graduated in electrical engineering 40 years ago, I have not used it that much. The best person to ask probably is one of my teammates. I really cannot answer that question. I'm not really an engineer, electrical engineer. I haven't been one for a very, very, very long time. What I've recommended since Tim has done an excellent job of pulling the various people together, I've recommended that my members move over to this group and participate in this group. You will find it a lot more informative because that was a non-Zoom environment where we were all physically present. And since COVID-19, everything has been shut down.
Okay.
Thank you. Great. I've dropped you an email, and I'd love to have a response for you on that. Sorry to cut you off, Tim. Just wanted to highlight.
That's okay.
Oh, no worries.
I will
Thank
try
you,
what I
Mohammed.
can. Usually, I tell people upfront that sometimes I do not reply to emails simply because I am overloaded with what I'm doing. But I will try and reply to what you have to say.
Well,
Okay.
yes, thank you. And I should apologize for rushing a little bit. We are getting low on time. I want to get Jeremiah in. Go ahead, sir.
I'll try to be quick about it. On the slide where you have the aluminum disc and you have another disc underneath it with either a magnet that's circular or a series of magnets, hard to tell from your picture. Those magnets are mounted onto some other material. My two questions for you are, what kind of magnetic field do those magnets have in that example where you say the axial force is converted into a linear force or an acceleration force? Is that correct?
The bar magnets is very much linear, but the gradient of the bar magnets obey 1/r² from the surface of the magnet. And that's the important consideration for the crude model. The disk magnets, the gradient obeys 1/r³.
So are you familiar with like with those videos online of Alexei's flying small craft? It's like a mini flying saucer with wires tethered to it that fall from underneath, and it looks like it's levitating. A lot of controversy about whether or not the videos are real, but there's this small levitating craft with a disc that has magnets on it that rotate underneath.
Alexei Cherkov in Russia.
Yeah. Are you familiar with that?
Yes.
Is
we
that
actually looked at it.
Something
We
like
actually
that?
looked at it. We studied it. We looked at all his videos, and then we sent him an email, invited him to come in and join us and talk to us about his device over Zoom, but he was very reluctant to do so. It was his excuse was about big corporations and the government and that sort of thing. So that's it, we dropped it. But he gave us, when you're doing this sort of things, you have to be a little bit gullible, but you don't stop at, I believe, or I don't believe. No, you don't stop at that point. You have to take it further, okay?
Right, but I mean, get back. I know we have a limited time, so I just want to kind of finish up the question so we can finish this, and anyone else that has one can get to it. So as far as Alexei's system goes, where he has these 6 circular magnets mounted to the disc underneath that rotates, and then that's rotating underneath an aluminum disc with like this divoted surface. Is that effectively what's in your picture? Something just like that?
Yes, it's effectively the same thing that Podklanov put forward.
And so then it doesn't matter what the disc is made of underneath, as long as it can hold the magnets and it doesn't affect their fields?
Yes, ideally you want something that cuts off the magnetic field at the bottom.
So ideally it'd be some kind of ferromagnetic material, like a lamination of iron or something that's magnetic?
I'm not a material scientist.
Oh, I mean, you would want the field to be on the bottom side of the magnets. You'd want all those fields to be connected through this material that they're on?
Yes, to be absorbed by the material so that you get an asymmetrical field structure.
Okay, that makes more sense now. Thanks. That makes a lot of sense. Perfect. Okay. Well, that answers my 2 questions. Thank you very much. Anyone else?
Thank you, Jeremiah. Yes. Let me go back to Jeremy Reese, sir.
I wanted to ask one more question to you about your model of space-time. What kind of what do you think space-time is? Are you an ether kind of guy, or you I mean, are Einstein relativity GR kind of guy? I wanted to get more elaboration on that.
I have no idea what space-time is. All I can tell right now is that it's a continuum where the ruler is changing. The velocity, the relative velocity changes the ruler. Why is space-time like that? I cannot answer. Because when we know why space-time is like that, we have a better understanding what space-time is. It may be a medium, it may be some continuum that we don't fully understand. But ether came out of pre-Einsteinian considerations, and the physics community, in order to break people away from that and think about space-time in new ways, they derided ether. That's the only way to break out of it. Now, are we going to do the same thing with Einstein? It's sacrilegious to ask that question. But obviously, from the examples I've presented, it's not space-time that's curved. It's the ruler that's curved. So what are we going to do next? It takes a really good mathematician to explain, to explore that piece.
Okay.
Absolutely. Thank you so much.
Thank you, Jeremy. Let me go to Mike next, sir.
Hi, now I'm unmuted. Yeah, I had a question there. When Solomon showed this picture of like a sphere with a thickness that he thought was time and mentioned, but there was no time travel. Are you thinking maybe the past is immutable to some degree? That instead
I
of it
can
being
barely hear you, Mike.
immutable- Oh, you can't hear me?
Yeah.
Oh,
Hey, Mike, you were part of this gravity modification today. You did a lot of the design work.
Yes, yeah. I worked on the design of the device for a while. Yeah, John and I. You mentioned us. Thanks for the shout out.
oh, yeah, Benjamin, Mike is asking, he's asking if the past is immutable. So I think in a sense, he may be asking if time travel is possible. That may be a corollary.
It's
Okay.
not quite the
My
same,
thinking-
really. Mhm.
Is that since everything is on this surface of expanding sphere, there's nothing inside. So it's not that it's immutable. It's just that it doesn't exist anymore.
Right. It's like there's only the now. There is no
Yes.
past or
And that
future.
and that now is that moment in now is the thickness of the shell, which I believe is measured by temporal reversibility.
Okay, and you think that might be related to the Planck constant somehow?
The what
Yeah, thickness.
constant?
The Planck constant?
I don't know. I really don't know.
Oh, okay.
If we Planck constant is something that comes out of quantum theory. If we replace quantum theory with something else, it might not even exist, because our ability to examine the world has now changed, because we use theories as an instrument to examine the world. So if you take away quantum theory and replace it with something else, Planck's constant might not exist. What I'm saying is sacrilege. But you look at general relativity. General relativity does not have Planck's constant in it. So
Right.
it depends on what the next, who and what next theories are going to be.
Okay. Well, Benjamin, thank you very much, sir. And I should apologize for cutting it short. We are just at our time. So again, let me meet you back out. I'm going to put it back on gallery view. Again, everyone, let's do an enormous hand for Benjamin T. Solomon. That was tremendous presentation. Beautiful slide decks. I absolutely loved it.